We shift gears heading into section 7.2, even though it's, we're going to do some of the same of solving equations, but the definition here, it's really in section 7.1. It says a system of linear equations in two variables x and y is a collection of linear equations, typically two of them, but it doesn't have to be, of the form ax plus by equals c. So ax plus by equals c, where a and b are not both 0, because the a, b, and c are real numbers. X and y are the variables you're trying to solve for. You're trying to figure out what x and y are. So if a and b are both 0, you're going to get 0 equals c. You don't have any variables in the equation. So that's why it's okay to have a is 0 and not b, or b is 0 not a, because that would leave one variable on the left. Okay, so as long as one variable is there, we're good. But they don't want to eliminate both of them. Okay, so you have an equation that looks like this. So x to the first power, y to the first power. That's why it's called linear. And you have a system. So you have several of these. Okay. A solution to a system is an ordered pair that satisfies each equation in the system. So an ordered pair to this would be, say, x, y. Let me give a specific example. If I had 2x plus 3y equals, 12. Yeah. And now, again, there'd be others. But what's a solution to this? 0, 4 is a solution, because when x is 0 and y is 4, you get 0 plus 12 is 12. Or 6, 0, because that'd be 12 plus 0 is 12. Okay, so a solution is when you plug in for x and y, it makes the equation true. Now, in a system of equations, you're going to have others, 3x minus 5y equals 15, or something like that. So to be a solution to a system, it's an ordered pair that makes both equations true. Or if you have 3 equations, it has to make all 3 equations true. So I don't know what the answer, I can't eyeball this and just tell you the answer, but if there is one, okay? So a solution to a system of linear equations in 2 variables, it's an ordered pair that makes every equation true. So that's what we're trying to find, all the ordered pairs that make all the equations true. Okay, now right, in college algebra you learn 3 methods of solving these sorts of things: graphing, or substitution, or elimination, which is also called the addition-subtraction method. That's the method I want to review with you in this section. Okay, now what types of solutions can exist? If you have 2, like I had before, I have 2 linear equations and 2 variables. Well, each one of those graphically, geometrically represents a line. So one of them could be a line like this in the plane. Another one could be a line like this. So what would make what would make both of those equations true? The point they share in common. So that's one possibility. If you have 2 equations, 2 linear equations, and 2 variables, a solution could just be a single point. Okay, that's one possibility. Another possibility is one of your equations represents a line like that, and the other equation is a line parallel to that. Okay, so any points on that line would make the first equation true. Any points on that line make the second equation true. But what makes both equations true simultaneously? Nothing, because they don't share any points in common, which means your system has no solution. Then the third possibility is, suppose the first equation is represented by that line, and then the second equation is the same line. So what points do those 2 lines have in common? Everything. There's an infinite solution. I'm not really concerned with infinite solutions here. I'm mainly concerned with the one solution and the no solution, because those are the things that pop up in calculus. Okay, let's do an example here. This one says, solve the system 5x plus 3y is 6, and 3x minus y equals 5. So we're trying to solve this system. So we're trying to find all ordered pairs, x, y, that make both equations true simultaneously. So again, in college algebra, you graph this one, and you saw where they intersected. The problem with that is it's not very accurate, Now, do you remember, we're not going to do substitution, but how did substitution work, that method? You picked one of the variables in one of the equations and solve for it. Here, the easiest to solve for would be y. So I would solve for y here, get y by itself, which would be 3x minus 5. And then you substitute 3x minus 5 in for y here. Then you'll have one equation and one variable you just solve. Okay? So we're not going to do that. I want to do elimination method, or addition-subtraction method. Alright, so the way that works is, what you want to do is get the coefficients of one of the variables to be the same, well, to match, except for be off by a minus sign. Okay, so that's what we want to do. So 5 and 3, you know, they don't match. I usually pick the one that's the easiest to match. For example, here I have 3y, there's a negative, so this is a plus and this is a minus. So all I've got to do is get a 3 here, and I'll have a 3 and a minus 3y. Okay? So what I'm going to do, I'm going to recopy the first equation, and I'm going to multiply the second equation through by 3. Remember, if you have an equation, if you multiply both sides by the same non-zero number, you'll still get you'll get an equation with the same solution set. So it doesn't change the solution. So I'm multiplying through by 3 here, so I get 9x minus 3y is 15. Sometimes it's helpful if you put a little code out here, like times 3, meaning I multiplied that equation by 3 to get this one, especially if it's several steps. I'm going to do that probably in the next section, especially if you get to the end and you realize you made a mistake. It's hard to go back and figure out what you did in each step. Okay, so the idea is that now that I have those opposite signs, notice if you have, you know, if this is equal to this and this is equal to that, adding these two things would be the same as adding those two things, because these are the same and these are the same. So that's what we're going to do. So if I add these two things together, 5x and 9x is 14x. 3y plus negative 3y is 0. The whole point was to get rid of that. If you don't eliminate a variable, you've done something wrong. And then that plus that, 6 plus 5 is 21. Notice I've eliminated, this is what's called the elimination method. I eliminated the variable y, so I'm left with one equation and one variable. So notice if you divide both sides by 14, x is 21 over 14, but you can reduce that fraction. 7 goes into both, that's 3 halves. So x is 3 halves. Okay, now remember, a solution is an ordered pair. We have to go and find y. Now, it doesn't matter which equation you plug into, because remember, the solution has to work in both. I'll just use the second one because y is plain. Okay, so now let me back substitute. So 3 times x, 3 halves, minus y is 5. So I'm plugging my 3 halves back into x here, and I have to figure out y. I could have plugged the 3 halves in for x here and figured out that y. I mean, either one is fine. Okay, how do you think of this as 3 over 1, multiply fractions, you get 9 halves minus y. Well, to get a common denominator, let me just go ahead and rewrite that 5 in terms of halves, so that's 10 over 2, isn't it? Right, 5 is 10 halves. I did that just to get the common denominator, save myself a little bit of work. So if I subtract 9 halves from both sides, I have a negative y is 10 halves minus 9 halves. So negative y, 10 halves minus 9 halves is 1 half, so y is negative 1 half. So what's the solution? I'm perfectly happy if it's just one ordered pair, if you just tell me the ordered pair. You don't have to write solution set is the set of order, you know, I'm not that concerned about that. I'm mainly concerned, can you get the solution? Now, you can always check your answer here, right? That ordered pair must satisfy both equations, right? So if I do 5 times 3 halves plus 3 times negative a half, I should get 6. Let me just do some scratch work to see if that works okay. I'm just checking my answer here. So 5 times 3 halves is 15 halves, plus 3 times negative a half is negative 3 halves. Notice that's 12 over 2, which is 6. Check. Now what if I check the other one? 3 times x, that's 3 times 3 halves is 9 halves. Minus y, that's minus a half is plus 1 half, and you get 10 over 2, which is 5. Check. So that's our solution. So it works just fine. Okay, let's do another one. I mean, this isn't a difficult section, so I'm only doing 2 examples. It says solve with the elimination method. 9x plus 7y is 2. 3x plus 7/3 y equals 1. Okay? So we're going to solve with the elimination method here. So which variable do you think we should mess with and try to match up the coefficients except for having opposite sign? think it's easier to match these just because they're integers. I mean, so, yeah, okay. So I'm going to leave the first equation alone, and I'm going to multiply the second equation by -3 to make a -9. So -3 times that is -9x. -3 times 7/3, the 3's cancel, I get -7y, and -3 times 1 is -3. Let me check myself. -3 times 3 is -9. -3 times 7/3, the 3's cancel, you're left with -7, and then -3, right. So I've got my 9 and my minus 9x. So if I add, like I did before, 9x and 9x is, and -9x is 0. 7y minus 7y is also 0. I get a 0 on that side. And then 2, I'm adding, right? 2 plus -3 is -1. And notice we've worked down to 0 equals -1, which is a false statement. So if there's a solution that makes this true and makes this true, you wind up with a problem. 0 equals -1 doesn't make any sense. So the way you interpret that is there's no solution. There is no ordered pair. These lines are parallel. That's what's happening here. Okay. Now if you work down to 0 equals 0, that's not a problem. That's not a no solution. 0 equals 0 is a true statement, okay? So if you work down to a true statement, that doesn't mean no solution. Typically that's an infinite solution. You'd have to go back and work on that. But I'm really concerned with, you should know the types of solutions, right? You either get a single order pair, you get no solution, or you get the lines are on top of themselves as an infinite solution. That you should know. But in terms of working things out, I'm really only concerned with no solution and one solution. So that's how you do section 7.2.